Alright, today we're going to be looking at pressure and Pascal's principle equations. So you're going to need your formula sheets and your calculators in order to complete the equations. Alright, so we're going to start off with our formula sheets. So we're going to put pressure for number 2, and for pressure equals F divided by A, or force divided by area. To solve for force, it's pressure times area, and to solve for area, it's force divided by pressure. So P equals pressure, F equals force, A equals area. Pressure is going to be in pascals, which is equal to a Newton per meter squared. Okay, but we're going to keep it as pascals when we put a unit there. Force is going to be in newtons, and your area is going to be meters squared. Now, for Pascal's principle, we're going to have to solve for just 3 out of the 4 variables, because it has 4 variables total, because your pressure in one area equals to pressure in another area. So therefore, you might every once in a while have to solve for your first force, which is going to be your second force times your first area divided by your second area. Most of the time you're going to solve for the second force, which is going to be your first area times your second area divided by your first area. And then when it comes time for solving for your areas, you're only going to have to solve for the second area. So you're going to have your second force times your first area divided by your first force. So therefore, when you're looking at this, you're going to have force, which is in newtons, and your area, which is going to be in meters squared. Sometimes they're going to give it to you in centimeters squared, but you're not going to have to convert it. They let you just solve it as is. Okay? So again, when you are looking at this, you're going to have a possibility of solving for the first force, most likely solving for the second force, and you're always going to be solving for the second area. Alright? So therefore, we're not even going to write down the first area there. Okay? So now you have your formulas, and they should be on your formula sheet there for pressure and Pascal. So we're going to look at some examples for pressure and Pascal. So we're going to start off with page 93. And we're going to look at the math skills there. And it says that in a car's liquid-filled hydraulic brake system, the master cylinder has an area of 0.5 centimeters squared, and the wheel cylinders have an area of 3 centimeters squared. If the force of 150 newtons is applied to the mass and cylinder by the brake pedal, what's the force, or how much force does each wheel cylinder exert on its brake pad? Okay, so this one we're going to be using F1, A1, F2, A2. And we know we're using Pascal's principle because there's 3 numbers given to us. If there's only 2 numbers, you'd be looking at using the pressure. If we have 3 numbers, we're going to be looking at Pascal's principle. So that first number they gave us was 0.5 centimeters squared. So that is going to be our area for first area. Then they told us we have 3 centimeters squared, so that's our second area. And they told us the original force on our master cylinder was 150 newtons. So therefore, we're solving for our second force. So second force is F1 A2 divided by A1. So we're going to have 150 times 3 divided by 0.5. So 150 times 3 will give us 450 divided by 0.5, which give us 900, since we're looking at a force, newtons for our answer. Okay, I'm going to look at page 94 now. Number 8. Okay, on page 94, number 8, it says a waterbed that has an area of 3.75 meters squared weighs 1,025 newtons. Find the pressure the waterbed exerts on the floor. So since there's only two numbers, that means we're using the pressure equation. So we're going to have P, F, and A. So our first number was 3.75 meters squared, so that's our area. Then we have 1,025 newtons, so that's our force. So pressure equals force divided by area. Okay, so we're using that first equation there. So 1,025 divided by 3.75 would give you 273.33 pascals. Okay, number 9. The small piston of a hydraulic lift has an area of 0.020 meters squared. A car weighing 12,000 newtons is mounted on the large piston with an area of 0.90 meters squared. What force must be applied to the small piston to support the car? Okay, so when we're looking at this, we have three numbers. So we're going to have F1 A1, F2 A2. So this one you have to pay attention to where's your beginning of what you're starting with. So that's going to be your ones, and what you're going to be your twos, where you're going to end up with. So if a car drives onto a large piston, that's where it's starting at. So when that occurs, your first force is going to be 12,000 newtons. Your first area is 0.9 meters squared. Your second area is going to be the 0.2 meters squared. So this is the one where you kind of have to look and see what the situation is to know what your ones and twos are going to be. But most often, they're just going to be in order for you to be able to solve. So in this case, we're solving for the second force again. So F1 A2 divided by A1. So in this case, we're going to have 12,000 times 0.02 divided by 0.9. So 12,000 times 0.02 will give you 240 divided by 0.9, which would give you 266.67 newtons. Okay, so there's examples we're going to do out of the book.